Hello, so today we're going to be looking at a reaction with this rate right here, and we want to know what would change the rate constant K. So really quickly, let's look at the Arrhenius equation. So we can see that the rate constant is dependent on the collision frequency, which is how quickly molecules can collide into each other, the activation energy, and the temperature. So now let's take a look at the different situations. So say we doubled the pressure of nitrogen dioxide. Well, that would probably increase the concentration of nitrogen dioxide here if the volume is held constant and so is the temperature. However, that while it would increase the rate, probably it would not change the K. So no change in K. Because as you can see, the concentration of nitrogen dioxide isn't part of this reaction here. Now let's take a look, and let's say instead of we run it in an organic solvent. So running it in an organic solvent would change how the molecules are moving and thus how often they would collide. So that would change this A here. So yes, our K would change. Now let's look at a situation where we doubled the volume. Now doubling the volume would halve the concentration here. However, as mentioned before, our K does not depend on the concentration of the reactant. The rate does, but the K remains the same. So no change in K. Now let's take a look at a situation where we've decreased the temperature. Well, our K depends on temperature. We can see it right here. So decreasing the temperature would make this coefficient more negative and thus would lead to a decrease in K. So decreasing the temperature decreases the rate constant, it decreases the rate. So now let's say we added a catalyst. Well, what does adding a catalyst do? Well, it decreases the activation energy. A catalyst lowers the activation energy. We see that our activation energy is right here. So changing the activation energy, lowering it with a catalyst, would make this less negative, and it would make K larger. So adding a catalyst would increase the rate constant. So there we go. We've looked at some situations and what can cause K to change.